Okay, class, so the last thing that we are going to look at in this unit is sort of just the application portion of what does this look like with story problems? What does this look like tying all these pieces together with functions and writing equations of lines and graphing lines, and what does that all mean? So if we look at this first problem up here, polar bears are listed as a threatened species. In 2005, there were about 25,000 polar bears in the world. The number of polar bears declines by 1,000 each year. You do not need to write all of those down. Instead, all those words down, this whole thing. Instead, I want you to just, again, be thinking about what we can do with this and how we can connect it to all of the options that we've talked about. So our first step is going to ask us to write an equation that models the number of polar bears for each year after 2005. So I want you to do your best to try and write that equation. So when we look at this, what we should have done, right, is we're saying, okay, well, y is going to equal, so like if we think about what our x and y would be, okay, it's declining by 1,000 each year, and we're starting with 25,000. Remember, our x variable is time. It's what's happening per item. So we have 25,000 polar bears to start with, and it's declining by 1,000 polar bears each year. Now, some of you may be thinking about this and then rewriting it and saying y equals negative 1,000 x plus 25,000. Okay, so when it says what does the slope represent, right? Slope is always what's in front of our x. Okay, so the slope is negative 1,000, but what does that represent? And remember, slope is always a y per an x, right? Y over x. So we would think about what our labels are. We already know that years is our x. And what are we calculating? We're calculating the number of polar bears. I'm going to abbreviate that with a B. So it's our polar bears per year. So we are losing 1,000 polar bears per year. That's what our slope represents. Our y-intercept is always represented with the letter B, and our y-intercept in this situation, right, is our 25,000. And when we think about our relating graphs to events, right, if we think about a graph and we think about what this specific graph would look like, I'm just making up a general graph here, right? We'd have a line that starts here and goes downhill. Okay, our y-intercept up here is telling us that starting point, right? When I was standing at the door, we started on the y-axis because that's before time had passed. Okay, so this $25,000 is representing the starting number of polar bears. Right? Our y-axis is always almost the starting point. Now we might have to think about what the starting means in relation to the problem. The x-intercept over here is then where we're ending. So this is when all the polar bears are gone. Okay? So using those concepts, we're going to look at a couple other ones and see how we do. So suppose you are doing a 5,000 piece puzzle. You have already placed 175 pieces. Every minute you place 10 more pieces. So we are going to write an equation in slope-intercept form that models the number of pieces placed. So you try that on your own first. So when we did this, we should have said we started out with 175 pieces being placed. Okay, and then every minute, we're adding 10 more pieces. So it's 10 pieces per minute. And that 5,000 actually had nothing to do with what we would write in our equation. Okay, it would be when we have the puzzle done, it would be our ending point, but it has nothing to do with how many pieces we have done per minute. Now we're asked to graph this. So if we want to graph this, we're going to kind of need to make sure we count carefully here. I'm not going to get all the way up to 5,000 because I don't think we need it for a good representation. Okay, I'm going to count down here, which is my time, my minutes, by 1. Now, I need to make at least 175 fit here, so I think I'm going to count by 25s. Okay, and I'm just going to follow my basic graphing rules now. I'm going to start at my y-intercept of 175, right? Make sure we understand that this is the same thing as y equals 10x plus 175. Okay, so my y-intercept is 175. Now I'm going to go up 10 and over 1. So I'm going to have to approximate a little. It's fine. I know I don't normally like approximating with graphing, but with numbers this large, it's kind of the best we can do. It now says, after 50 more minutes, how many pieces will you have placed? Okay, so after 50 minutes have passed, you have 175 pieces done. After 50 minutes have passed, how many pieces will you have placed? So you should have taken this 50 and plugged it in for x. So we'll say 500 plus 175, and we should have got an answer of 675 pieces. Okay, so suppose you have a $5 off coupon at a fabric store. You buy fabric that costs $7.50 per yard. We are going to write an equation that models the total amount of money, Y, we're going to call that Y, you pay if you buy X yards of fabric. So if we look at this, okay, we want to write the equation. We're going to say Y equals, we're paying $7.50 per yard. So whenever something's happening per yard, it gets a variable, which it tells us is X. But this time I'm saving $5 off. So I'm going to subtract that 5. Now we want to take this information and we want to graph it. So if we graph this is a little bit difficult to think about, right? Our y-intercept here is actually -5. So we're going to have to extend down on our graph to get the right idea that we want here. Now, because this is counting by 750, you might think about each half of a space as being 50 cents. So if I go down by $1, 1, 2, 3, 4, 5, right? So -5 is here. Okay. And I want to go up 750. So from here, I'm going up 7. 1, 2, 3, 4, 5, 6, 7, and 50 cents. So I'm going halfway in between, over 1. Okay, now I'm going up 1, 2, 3, 4, 5, 6, 7, 50 over 1. So this would be my line. Oh dear, that was a terrible line, but pretend it's straight. No assignment today, just make sure you're okay with these concepts. Otherwise, make sure you're ready for your test on Friday. If you are Gold Day, if you are Green Day, we'll be reviewing in class tomorrow.